18, the x will then become 1 minus 1. So just back to, oh, let me just, sorry, I forgot to record, so let me just, oh, okay, so thank goodness somebody did start the recording. Sure, thank you, Bronwyn. Okay, let's go back to the example, and can you still see it? Please just show me again, thumbs up if you can still see it. Or if I need to share again, so thumbs up if you can still see the screen. Cool, awesome, thank you guys. Okay, so basically then we sit with the 6x minus 18, and because it's differentiation, it's equal to 0. So we'll get the 6x is equal to 18, and by that way we can get x is equal to 3. And there you can see it is the x equal to 3. Then basically how to get to your y point again, you put that 3 back into your original equation. So if we do that, we get, and I think this is the best way where I explained it here, you've got your 3 to the power of 2, which gives you 9. 9 times 3 gives you the 27. Minus 18 times 3, that I'm gonna now nearly guess, that gives us around minus 54, plus 34, so let's quickly check. So if I do that calculation, that would have given me minus 20, so 27 minus 20 gives us the 7, which is correct there. So your y value is basically 7. So your turning point would have been, if we need to write it, is always your x first. So your turning point is always written as xy. So we have the x is equal to 3 and the y is equal to 7. If I ask you what is that value where the line cuts the y-intercept, that value is basically that. So that is where your y-intercept of the parabola is 34. So this is the, if I can say it, the more easier one where they say, if you have a function to the power of 2 and you need to work out the coordinates of a turning point, that's the easier one. If we go to the next one, so now you see we've got x to the power of 3, x to the power of 2, and to x. So that already tells me there's going to be 2 turning points. And I think the way that we need to look at this is, so if your highest x is to the power of 3, you will have 2 turning points. If your x is to the power of 2, you will have 1 turning point. And that's why if you have just the straight line, you actually have 0 turning points. And I think that is also an indication when you're in the exam, if I ask you to work out something and specifically turning point, and if they give you a certain amount of x's, that is also nearly a way of getting to the answer. So, or not getting to the answer, but eliminating some of the answers. So if you know there needs to be 3 x's and they only give you 2 values, then you know that can't be one of our options. Okay, so basically when we look at this one, we do the same principle as we did with the previous one. It just becomes a little bit more difficult where here we only had to work out one x, so it was actually in a sense very easy. Here it becomes difficult because we will need to work out two x's. So let's first derive that. So it will be then the normal, I'll take the 3 in front. Let's just imagine that was a 3. The same then we do, and I'll do this every time because just to basically repeat what we've done last week. So remember, it will be 3 minus 2 at the top. So then let's do the 9 times 2 is 18. X again, 2 minus 1. Minus 24x will become minus 24. And let's just write that 1 minus 1. And the 26 will disappear because it is a constant. Okay, so if we rewrite that, it's minus 3x to the power of 2 plus 18x minus 24. So the first thing I would do here is, okay, there's a negative 3 in front of the x squared, so maybe I want to get rid of that. But also what I see is, here's a 3 in there, I can divide by 3 as well, and there I can divide by 3 as well. So in each of them I can actually divide by 3 to make it easier, and I actually divide by minus 3. So what will be left here is the x squared. 18 divided by minus 3 is minus 6x. And minus 24 divided by 3 gives you plus 8. So now we need to calculate what the two x values will be, but we first need to factorize it. So luckily with this one, there's an easy way to do a factorization. So also how I normally look at it is, I say, okay, remember there's a 1 in front of the x squared. So what times what can give me a 1, and it's actually only 1 times 1. Then I'm looking at the 8, so I'm deciding, okay, so what do I do to get 8? So I can say, well, 8 times 1 can give me 8. The other one is 4 times 2 can give me 8. And that's basically it. I can't think of another one. So if we need to get the middle term, when I need to say 8 times or 1 times 8, that times that, if I subtract the 2, I'll get 7. So that's not the option. If I add the 2, it will give me 9. So that's not the option. Okay, so let's look at the 4 and the 2. So if I said 1 times 4, it will give me 4. 1 times 2 will give me 2. 4 times or 4 plus 2 will give me 6. Okay, cool. So there I have my two factors that I'm going to use. And I first write the 4 and the 2, and we'll get to the minus and the plus now. So I know from the maths that to get a positive, it can be two ways. So, or I can say a minus times a minus, or I can say a plus times a plus. Okay, so that's the two ways that I can get to that positive x, or the positive. So then I say, okay, well, let's look at what is in the middle term, and that's a minus. So that tells me but I will need to work with the two minuses because I need to get to that minus. So it will be x minus 4, x minus 2. And then basically your x will be equal to 4, or your x will be equal to 2. So you'll see from here, there's your one turning point of 2, and there's your other turning point of 4. You still don't know which way it is turning, and I think that is also important to note, that if you want to draw it for yourself, what I would do is I would make my point, or I would draw a dotted line through where it is 2. I'll draw a dotted line through where it's 4. I would have looked at that positive 26, so I would have said, okay, it needs to go through there. So wherever I then do is I would have said, okay, somewhere there it would do a turn, and somewhere there it would do a turn. So now we need to find out what is that y and what is that y values. So the way you do it is by putting that 4 back into the formula. And I think what is important is in which formula do you put it back. So if you put it back into that formula, will it work? So, and I think that is for me the important thing. So if you put it back into that formula, you would have seen that you're actually working out this again. And if you're working out this, you will get a 0. So you need to put that 4 back into the original formula to get your y. And you need to put in the 2 back into your original formula to get the other y. So I think that is the important thing, is sometimes it's very easy to think, okay, now I've got my new derivative formula to work out the turning point, and I will use that for my y, but you actually need to go back to your original formula to get to your y's. And I think that's probably, okay, no, it's not even explained here. Okay, that's quite interesting. I haven't shown here. No, they haven't. Okay, so I think that is just the important thing that we haven't done here, and maybe we get to it later. So to get that y, you need to put the 2 into the original. To get to that y, you need to put in the 4 into the original formula. Okay, and nearly a lot of the things that we'll see in chapter 6 will be nearly around this. So nearly the things that we've done in chapter 5 will be used in chapter 6. So yes, we'll talk about it as maybe the average formula for one thing, or the average for the other thing, or marginal, but actually it is the work around chapter 5. So I think that is why it's an important chapter 5, because a lot of the work in chapter 6 is basically what you did in chapter 5. Okay, so can we go into chapter 6? Let's just get a few thumbs up. If there's anything I need to repeat on the previous one, you can ask that as well. I am following the chat on my cell, so I can see at least if you guys are saying anything. Okay, cool. So there's at least one thumbs up. Okay, so I just included in the start of the chapter the learning objectives. So I'm not really going to go into there. I think what is important, and with the work you've been doing for the assignments as well, suddenly we now are faced with, we did in chapter 3 or 4 somewhere some of the demand curves, and then we went into differentiation, which felt weird that they are bringing in much more critical maths into to this, that at that point the link wasn't really clear. But now basically when we look at the marginal and average cost or average functions, then we need to know nearly, the important thing is this. So that for me is, if you look at what we need to know, that is nearly the summary of it. So you need to know what your total revenue is. So if I ask what total revenue is, or if I ask what marginal revenue is, or what average revenue is, that you nearly know what to do or how to get there. And I think that for me is nearly the critical part of this chapter, is we need to understand that, or when we get something, can relate it back into one of these. I don't know why my initials are now with me, but that is also fine. So basically the first one, so we'll try to cover these ones today. I think we'll probably do all of them, and nearly it's if you have that, it's easy to do that one. So I think the first thing that we nearly need to get to is, we need to look at the marginal functions, and then it is easy to work out the average. Okay, so let's get back into this. So now we need to go back to some of our previous chapters where we said, okay, total revenue. So total revenue, what was that again? Okay, we remember from total revenue it was P times Q, but now we also have a function for P, and I think that is where it now becomes very interesting. So here you have the function for P. So this is again more on the definition side, but how to get to it. So your total revenue would have been P times Q. For P, you would have a formula, and if I think back into nearly assignment 1 and assignment 2, when we looked at some of the demand and supply functions, we always had the P simple function that they give us. So we never went to the next level of multiplying it out. So if we then multiply it out, you will see that you will always get nearly a function with a to a power of 2. Sure, that now looks nearly terrible that you can't see it. So always to the power of 2. So that means that I can start differentiating that function. If it's not to the power of 2, doesn't mean that you can't differentiate. You will just get a constant in the end. So I don't think I have seen anything like that, but maybe we'll get 1 or 2 weird ones in some of the previous exam papers or some of the previous assignments that we can go through to see if there's any. But okay, so the next step is, we've got our total revenue. So if we basically differentiate the total revenue, we will get our marginal revenue. So if I look at that function of AQ minus BQ to the power of 2, so if I needed to do the differentiation here, we would have again said 1 minus 1. Here we would have said, okay, so we need to take the 2 to the front. So minus 2b, q will be 2 minus 1. And then that will give us q1 minus 1 is actually q of 0. Q of 0 falls away, so we have a. Here we have 2. Nothing changes with the b, so we have b. And then q2 minus 1, so we get that. And normally then they would give you a point or something that you can put in. But so that is how we get from a total revenue to the marginal revenue. And in the exam, they can use this in a few different ways. So they can give you the total revenue and say you need to work out the marginal revenue and the average revenue or something like that. Or they can tell you, well, you have this price function, you have the quantity, so you then first need to work out the total revenue function and then get your marginal revenue function. So they can ask it in a few different ways. But I think let's go into another example so that we can just get our heads around it, if that is okay with everyone. So let's just quickly now again check into this one. So in this example, they tell us that is your demand function. So then we can say total revenue is equal to P times Q. Okay, so then we can say, but let's replace the P because we now have the P. So let's replace it. So I like to write that in front just so that it is easier to work with. Okay. So we're still busy with our total revenue function. So 6 times Q gives me 6Q. Q times minus 0.5Q basically gives me minus 0.5 Q to the power of 2. Okay, so I've got our total revenue. So from our total revenue, to get to our marginal revenue, we basically need to differentiate that equation. So we need to differentiate 6Q minus 0.5 Q to the power of 2. Okay, so basically that will give me, if I differentiate that, it will give me 6. If I differentiate this, let's just 0.5 times 2 to the power of, or times Q. So that will give me 6 minus 0.5 times 2 gives me 1. So we've got 6 minus Q. Okay, so that is our marginal revenue curve. So then what do we do next? So they will tell you if we need to put in, so like they've said here, from the marginal revenue, we find that when we sell 5 units, so they will need to tell you, okay, you sell 4 units, what is your marginal revenue? You sell 3 units, what is your marginal revenue? So they will need to tell you what value you need to put into Q to get to a rand value for the marginal revenue. Otherwise, it stays in that formula. And I think that is in the other important thing is they need to give you some values so that you can actually work out the rest, but normally they do. So they would normally tell you that the Q is equal to, in this instance, 5, and work out the marginal revenue. And I think that is also important, that is sometimes what they do then is, so they tell you the Q is equal to 5, work out marginal revenue, and then suddenly when you see that, you're nearly like, oh, I just put in the Q into that formula because that's what you now think, but it needs to go back to the steps. So first work out total revenue. You need to get your total revenue function, derive that to get to your marginal revenue. Okay, so that is basically the importance of nearly, if we go back to, where was that other one? So if we go back to that, I think that is again where it is important to remember which ones are linked to one another. So the total revenue linked to marginal revenue. Okay, so that one we've done now. So let's go back to that. So I'm happy that we covered marginal revenue. If you guys are happy, let's go to the next one. Just give me a few thumbs up again if you're happy, or if I must return to anything else. Okay, are you guys happy? Must I return to the previous one again, or can we go? Okay, awesome. And basically, nearly, if you understand what we did in chapter 5 now, the picture for the rest is nearly every time the same. The difference is in more of a complexity in what was those formulas. So it nearly becomes into what's the complexity in those ones. So if that is complex, then your first variation will be complex. Otherwise, if it is a simple one, it actually is not too bad. So first, let's make this a bit bigger so that we can just look at it as we go along. So again, to get to marginal cost, it will be the derivative of total cost. So I think that already is where we need to remember the link. And total cost is normally fixed cost plus variable cost. Okay, and you'll see here as well, that is normally how we do it. So the question now is, what is the fixed cost and variable cost definitions or formulas going to look like? So is it possible that we can, and I know here they say we need to do the fixed cost, the derivative of a one plus derivative of the other ones to get to the, so, but it can be that it's easier to put the two together. So it depends on what the formula is that we have, is that we need to look at. So let's see in an example, what do we have? So what is nice with this example, and I don't think that is how it will be in the exam, but hopefully it can be. Here they have given you what the total cost is. So you actually, in this instance, don't need to worry about the fixed cost. You don't need to worry about what the variable cost is. To work your marginal cost, you just take the first derivative of this formula. And this formula was an easy one. It's 100 plus 40Q. So that will disappear. What will happen with a 40Q? That will be just become 40. So your marginal cost in this instance, very easy. It is 40. Nothing trying to catch you out. Here it was, they have given you the total cost, and from total cost we can directly go to marginal cost. Okay, so the next one, again, total cost. So here in the total cost, they already made, as you can see, there's a Q3, Q2. So here they already did the calculation of a fixed cost and the variable cost together. That is why it looks like a very difficult one. But to get to marginal cost, simple, we differentiate again. So let's start differentiating. So we have the 1/3, the 1/3. So we multiply that by 3. So how I normally like to write it is 3/1, so that we can just cancel things out. The normal way, Q minus 1. Okay, so that one is sorted. We've got the 8. We need to multiply it by the 2. The Q becomes 2 minus 1. And then the last one is plus 120. I'm not going to write the Q 1 minus 1 anymore. So that is, and we don't have any constant, that falls away. So the next step is, so if we do that, that cancels out, that cancels out. So basically we sit with Q to the power of 2 minus 16 Q plus 120. Okay, so this is your marginal cost function. So with this one now they need to tell you the value of Q. So don't go into now trying to factorize this out. That you don't need to draw a curve, you don't need to do anything. What you need to do here is you need to calculate what is the marginal cost going to be. So they need to give you a Q value that you put into your marginal cost. So they give you Q is equal to 15. So when you put 15 in there, 15 to the power of 2 minus 16 times 15 plus 120, and that will be your marginal cost. Okay, so don't go into any factorization or anything like that. They tell you marginal cost that you need to calculate when Q is 15. So we know now that the marginal cost, if we calculate that out, is 105. So in normal exams, they could, and they can still ask that in if it's an online exam, so they can ask you, but what does that actually mean? So yes, great, I know how to work out total cost, I know how to work out my marginal cost, but what does that actually mean? So what it means is it will cost me 105 Rand to produce one more unit. So to produce the 16th unit, it will cost me 105 Rand. So that is basically what you're working out. So when you look at so the next one will be probably total, or what is it? So your revenue curve. So basically at a point we will need to decide, okay, with your total cost, your total revenue, does it make sense to produce more units at a certain point? So that is basically what these equations are teaching you to do. Okay, so again, if we understood chapter 5, then this one becomes a little bit more easier. Can't you differentiate? Let's quickly. Siska, you okay, so you can't differentiate more because they haven't asked you. So you already did differentiate your first that equation once. Okay, so that is, so when we work out marginal cost, basically it is your first derivative of the total cost. So, and what you now asking, so your next derivative will be, if you want to derive it further, let's quickly see if we'll go back to here. So there wasn't at the moment that you need to go to the next level to do differentiation again. So for this piece of work, to calculate marginal cost, you basically stop here and you fill in the Q what is needed. So if you derived it another, you basically getting a different, and it's not even marginal cost, you're basically going further into the economics that you want to go into. So you don't derive at this point another one. So it's not that you, and I think that is important, it's not that you go on with derivatives until you can't anymore. I think that is very important to note that so even if you start with a x to the power of 4, and that was your total cost, your marginal cost will just be then the first derivative of that. Don't go into until I can't derive anymore. And I think that is also sometimes that one looks at it and it's like, okay, there's another Q2, I need to derive another further point. So if you derived, no, don't. I think it's important that you ask that point, because I think that is also when you looked at the derivatives that we did in chapter 5, it was nearly what we did every time is you derive, then you get to your x's, you get the turning point, you get all of that. So it's the maths nearly wants to tell you to go on and on and on, but that's where this subject is a bit more difficult because it is the economics with it. So that is why for marginal cost, you basically stop at the first derivative of a total cost. Okay, so let's look at the average. And I think the average is, in a sense, if you understand how the total was calculated, then the average is very easy. So the average revenue is basically just your total revenue divided by Q. So let's say if you look at that formula, very simple, your average is your total revenue divided by Q. So we could have, where was that? So that nearly all of them, I don't want to say all of them because some of it might differ, but it's looking at your total. So whatever your total formula is divided by Q nearly. But let's just see if there is any different ones in between. So and now with that, you can see they just give you, so total revenue can also be then classified. So if we multiply out by Q, total revenue can also be average revenue times Q. And I think what is important here is, again, that when you look at that, and you now need to link it back to, okay, so what will be my marginal revenue? So they can start giving you formulas for average revenue. They can give you what the Q is, so that you need to work out the total revenue and then need to work out the marginal revenue. So I think more important in this part of the work is that it's not about the simple way of saying total revenue divided by Q gives me my average revenue. The same with total cost divided by Q gives me my average cost. It is to understand that there is a link with this to get to your marginal revenue or your marginal cost again. I think that is more of a, even if I don't say it up front here straight to you, that is nearly the link for me, is that depending on how they ask a question, it can be different. Okay, so to work out the averages for the average revenue and average cost is quite straightforward, so we're not going to go into that too much. We'll do one or two examples. So let's look at what they tell us here. So here they tell us, okay, P is equal to 20, and so if we just did a normal total revenue equation where we set total revenue as we know it is P times Q, and I think that is also important just to note that down somewhere, because that is nearly every time going to be our reference frame. But if we substitute the 20 in, we get total revenue is equal to 20 divided by Q. So now if I said to us work out the average revenue, we know average revenue is total revenue divided by Q. So let's just, is total revenue divided by Q. So for this one, it would have been a simple calculation of 20Q divided by Q. So just imagine that was Q. Let's just do that a bit better for guys that are not, let's just reading the recording later on. Okay, so your average revenue was basically 20. So that is in this instance very easy to do. What is also very interesting in this instance, and it's not always like that, so your total revenue was 20Q. So if we calculated marginal revenue, we would have said Q1 minus 1, so Q would have fallen away, so our marginal revenue would have been also 20. Okay, it's not always like that, so I think that is the important thing. Don't think it is like that every time, but that basically means that for this one, this instance, the marginal revenue is equal to your average revenue, and that was actually even equal to the original P that they gave us. Please, it's not always the same. As you will see in this one, your marginal revenue and your average revenue not the same. So for this one, by how it is defined was the same, but it's not always like that. Okay, so here they talked about, and I don't think you guys need to worry about this. It's not economics that we're doing. We're doing a combination of economics and maths. So This is more about if you go back into your economics, what we talk about the perfect competitive firm, and that is why when you look at a perfect competitive firm, that is normally what you will get. But the other one that we can look at is a monopolistic firm. So let's look at that. So always the formula total revenue equal to P times Q, and I think that is nearly becoming boring now, but it is, I think it's good that we do it every time that you write it down. It nearly gives you that picture of, okay, the next step is, so the next step is they give you the P, you basically put the P into there to substitute. So your total revenue, and I always like to write my Q up in front. It's just for me that I don't make then other mistakes. So your 50 minus 2Q. So that gives you 50Q minus 2Q to the power of 2. Okay, so that is your total revenue. So to get to your average revenue, we would have said average revenue is my total revenue divided by Q. So my average revenue would have been 50Q minus 2Q2 divided by Q, and then there's a Q up there, there's a Q up there, so I actually nearly want to say, let's, if you look at that, it's nearly, we could have nearly gone back to that point, and have written it as what was original. Because that then makes it easy for me to say, okay, I can cancel those out. So for average revenue, it was easy to calculate. It was basically 50 minus 2Q, and we could have gotten it from there nearly when we said Q times 50 minus 2Q. Also, in a sense, if you go back to that original formula, your average revenue is actually equal to P. And I think that is just because out of the maths, if you say P times Q divided by Q to get to your average revenue, so it's basically your average revenue is equal to P, and it is always like that. So even if you looked at when we did it here, it was equal to P as well. So your average revenue, if you're ever struggling with it, it is actually your P value. Okay, so just from that point to get to your marginal revenue, so the first derivative of that, so let's just quickly do that again. So 50Q, so again, Q1 minus 1, the Q falls away. We bring that 2 up front, so we still have a minus. 2 times 2 is 4. We still have a Q. Q2 minus 1 basically gives me the 1. So your marginal revenue is the 50 minus the 4Q. And now you can see that that is not the same. So like the first one, it is not always the same. So I think that is the important thing to remember. But basically, you get your total revenue. You remember that your total revenue is always calculated with the formula P times Q. They will give you the P value. You then work out what is your total revenue in that formula. First derivative of that gives you your marginal revenue. If you need to work out your average revenue is actually just equal to the P. Okay, so that is nearly a quick summary of that, but I think there's one more that is probably a bit more difficult. So I think we'll always need to look at the difficult ones as well, because that is probably how it's going to be in the exam. So now they tell us, and I think that is now the important thing of how we link everything together. So now they tell us that given that the average cost function of a certain product is that. Okay. So what have we learned out of average cost function? So we can remember that average cost function is basically equal to P. So when we do total cost, we can say it's with P times Q, like we always start off with. And in this instance, we know P is equal to the average cost. So we can say it's the average cost function times Q. Okay, so, and I think that again just shows the link between all of these things. So that if I give you in the exam the equation that's marginal revenue, you need to work with it. If I give you the average cost, you need to work with it. If I give you the total cost, you need to work with it. So there's a few ways that they can ask it. So then basically, if we do that, now we need to, and I just want to write it over again. So I always, like I said, want to do a Q in front. So Q times AC. AC was 2Q plus 5 plus 50 over Q. Okay, so I need to multiply that into that equation. So then I get Q times 2Q gives me 2Q to the power of 2. Q times 5 gives me plus 5Q. And then that, I just want to do that here on its own. So 50 over Q times Q, and I then would write it as Q over 1. So the Q's will cancel one out. So basically, Q times 50 over Q is equal to 50. Okay, so now I have my total cost function. So now the next thing, they will now need to tell you what next. So just by giving you that, you have worked out what the total cost function is. So if there is anything next to do with it, they need to tell you. So my first thing is, if I would say, okay, but let's look at it and let's work out a marginal cost. When marginal cost is just the first derivative of that. So in that we know the 50 will again fall away. So it will be 2Q2. So it will be 2 times 2, which will give you 4. The Q2 minus 1, so that will be Q. 5Q, if we do a derivative of that, or differentiation of that, it is plus 5. So you will see that the marginal cost is 4Q plus 5. So now, if I then said, okay, for Q, you have basically 50 units, 60 units, whatever that you need to produce, then you will replace that with 50 and 60 or 70 or whatever it is to get to the next one. And that is to basically work out what the marginal cost will be to produce one additional unit. The other important point is, out of this, we could look at that and sure, this is actually quite a huge statement that they make here. But I think why they say it is, so for a fixed cost, you basically, that is the cost to produce whatever the is that you are producing. So it doesn't, there's no dependence on how many you produce. So when you look at that formula and you need to identify the fixed cost of that, it can only be the plus 30. That can only be your fixed cost because there's no Q associated to it. So when there's a Q, that tells me the more I produce, the cost will change. So that will be my variable cost. And I think that is the importance in here, is how they got to it. So when it's fixed, there can't be a Q linked to it. When there's a Q linked to it, then it is part of your variable cost. So I first thought, okay, it was, they quickly jumped to a conclusion here, but it is as simple as that a fixed cost is a cost that will be accumulated. You can't link any number of how many units you produce to it. So that is basically the constant of that formula. Okay, so I hope people understand that. Just give me a thumbs up, because I think this is also one that I think for people to, just by simply looking at the formula to get to that, was not as easy. And it is, the link is more to say that if it is a constant, there's no Q, so that is why it's a fixed cost. Okay, so let's go to the next one. So we've done, is there somebody want to ask something? You can also ask on the chat. So basically, we've done now the total revenue, we've done total cost, we have done, in a sense, the fixed cost and the variable cost. So we are fine with that at the moment. So let's see what are the next set of things. Okay, production functions. So just please mute. Thank you. Okay, cool. So let's just, and as people have joined, also at the beginning, I nearly said there is, and I think it's a good time now, there is a WhatsApp group. So if you're new to this session, first time that you're in this, there's a WhatsApp group that we have that I can add you to. So jot down my number, 083-790-8387. Send me a WhatsApp afterwards, and I'll add you to the group, and we discuss some of the things on there as well. Okay, so let's go to the next one. So production functions, and I nearly want to say this is one that I can't remember anything nearly in the exams or in the questions in the assignments on that. So it doesn't say it's not important, but it is also important to just, from a sense of view, if they want to want to ask something like that, I think it is important from that point of view that we just look at this as well, because if you later on see, we'll nearly jump straight then into more of economic functions. So I think from a production function as well, that we need to just see what is the definitions. Again, how they define it, and also important nearly is, and I'll, as we are finished with chapter 8, I'll basically write out 1 or 2 pages for you as well on what the important functions is that you will need to know, or not need to know in the exams, but need how you use it in the exam. Also, it will be interesting now to see if it's the online exam, again, if I give you tables, or not tables, but some of the equations, and if you can use your textbook or open book to do that. So, but if we basically look at one of the examples again, it's the same process that we will follow. So if we need to basically work out, again, if we have a daily production function and we need to work out what is the numbers employed per day, we look at that function, and to get to your marginal product of labor, we will need to do differentiation on that. So it is basically the same process, the same process that we will do here again. Differentiate that, so it will be the 15 times 2, the t2 minus 1 basically gives me t to the power of 1, and then we still have a minus, so 3 times 0.5, just to get into the space. 3 times 0.5 is 1.5. T3 times minus 1 gives me the T2. So here it would have been 30T minus 1.5 T to the power of 2. Okay, and then again, as in the previous work, they would now need to tell you what you need to do next. So they will need to tell you, well, when 10 workers, what is the next thing? So they can't just now again expect you to from there get to an answer. They will now need to tell you, okay, what is the thing that you need to work with? Sorry, that wasn't T, that was L. So sorry. Let's just because we're working with labor, we're not working with time. I don't know why I just assumed it is. Okay, so let's just do that. Just think of it as that is a L. Okay, so they will need to tell us again what is your labor per day. So the same here, if we now need to look at average product of labor, it is your Q divided by the labor. So again, think of it out of your total cost or and you needed to get to the average, you basically divide it by Q. So here it would have been that function divided by L. And that would have then given you, so if we just do that, and I think that let's just L to the power of 3. So we need to divide that by L. So what is left there will be 15 L minus 0.5 L to the power of 2. Okay, and once again, that is not exactly the same as that. So I think again it is very important out of this one as well that it was just that one example that the things were equal. So I think again going forward, be very careful when you work out the average and the marginal one, that it is not always the same. But again here they need to tell you what, so how many workers. They need to tell you. You can't just suddenly know what to put in there, or it's not that there's equilibrium or anything like that. They will need to tell you. Okay, so if you look at the production functions compared to how many of the other work we've covered, so that's why I'm like, don't want to say it's not important, but it's a very short part of what's discussed in your study notes. I can't remember anything of this nearly, so it's like don't want to say not to focus on it, because nearly if you know what to do in the previous work, you will be able to do this, because it again is just basically taking, if you need to work out the marginal one, you need to differentiate. If you need to work out the average, you basically divide. Okay, so I think we can go on to the next one if everybody else is happy with that. Because now again, it is the next few slides, I think again shows just a few examples where we will again go through the same nearly process, but again, I think it's important that it's nearly just revision of some of the work. Here they ask it a bit differently. So again, look at the differences in what we've worked out this morning, in how they can ask it in the exam as well. So they can, if you nearly go back to that table at the beginning, they can nearly ask it out of any of those kind of angles to work it out. So let's quickly look at this one. We're working with a demand function. They need to tell you what the demand function is. So we can, out of our total revenue, we can easily get to what we need to. It's P times Q. And that's just, that was supposed to be a Q. So we can easily get to what the total revenue is. So that is 100 Q minus 2Q to the power of 2. Okay, so total revenue done. That is easy. That's always P times Q. So they can only ask you a few things. So they can now ask you, what is your marginal revenue? Okay, so if you need to work out marginal revenue, you basically need to do the differentiation of that. So marginal revenue is, if we just do a differentiation, it will be Q1 minus 1, so the Q will basically disappear. 2 times 2 will give me minus 4, and here it is the Q2 minus 1, so we're basically sitting with just Q. Okay, so marginal revenue done. Okay, so now they need to tell us, okay, so now they're bringing in the work that we've done nearly at the beginning of the morning, to say, okay, so let's work out what is my turning point of the total revenue curve. Okay, so if we had that as my total revenue curve, I'm just drawing one. So your marginal revenue is basically the line that goes through that turning point. So that is what you will then use to determine that turning point. So and that's why we did the first derivative here at the beginning of the morning. So that marginal revenue, that curve is going through that turning point. So if we then need to work out what my Q and my P is, we're equal to 0, so 100 will be equal to before Q. So Q is equal to 25. Okay, and then if we then need to get to what the P value is, we basically put that value of Q equal to 25 back into the original. So we can, it will be interesting if we put it back in there, and if we put it back in there, if it will give you the same answer. So because I am looking at that point, I would have put it back into that one, because that is the curve that we are looking for, the turning point. I don't think they ask us here to do it. Oh, okay, so they've actually done it. So basically the price would have been 1250. I don't have my calculator with me at the moment, but we have calculated at 25 units. We need to put that 25 back into that formula, and that would have then given us the P value. So basically, we get the marginal revenue. If you want to get to the turning point of a marginal revenue, you need to make it equal to 0. You get your Q, you get your P, and then you have your turning point. So what we've also done here, and Siska, this is nearly where the part that you talked about going to differentiate again. So the second derivative, what we're talking here about is, if you look at that formula, the second derivative would have been a -4. And because that is less than 0, so that is where you're working out what your turning point, how it will look like, and those kind of things. So there was, in your question, this is basically what you would have done if you gotten, or if you worked out the second derivative. So you would have then looked at it if it was a maximum or minimum point. So, okay, Mario, yes, we do. So remember with a question, why don't we put it into the regional? Your regional is your total revenue. So your regional is the one that we have to need to calculate still. That was only your P. So we need to work with your regional, which is your total revenue function. So your total revenue function was the one that we calculated here. So that is why we still needed to go back to this one, because that is actually your regional. This was only a part of that original. Okay, so that is why when we worked out the P, we needed to go back to that function, because that is, in a sense, your original. Okay, and I think that from Siska's point previously, and now your point as well, and I think that is so important, why it's nearly, one needs to understand how everything flows into one another, because you want to work out the next derivative, but there's a reason only why you need to do that. And that is when they ask you about, is it a maximum or is it a minimum point? The same with the total revenue versus the formula that they give you. And I think that is always the difficult part, is especially in the exam when one has nearly studied certain things and you've done certain examples, so it's nearly the things are flowing. You see in the exam, oh, there's the function, I need to use that function, and in a sense forgetting that, oh, but I only used that part that is now so standing out for me in the exam as part of the total revenue. And the same, Cisco, with what the second derivative, if you go through everything, it's nearly like sometimes you're writing all the steps, you're working out all the things, and then sometimes they can give you an answer that is there, that was a step that you did extra that wasn't needed, and nearly trying to catch you out as well. So, and Maria, with the question that you asked, trust me, in the exam, there will be an option for you if you put that 25 back into that original P equal 100 minus 2Q. They will give you that option as an answer. So that is why it's important to remember to go back to your total revenue, because it is nearly, they will make sure that the mistake that you are nearly likely to make, there is an answer for you. Okay, so in here, very important again, the steps: total revenue, marginal revenue, and then if we need to work out the turning point, we basically need to put the marginal revenue equal to R. Okay, equal to 0. So let's look at another example. So now this one is a bit more difficult, and I think now if you look at some of the things that we again did in the previous chapter, some of the logs and exponential, now they're throwing those two into one. So now again, it's very, very important to keep focus on what to do here. So, and I think this is probably, let's look at the next one. Now this is probably the most difficult it will get in this, because this is not straightforward. But let's follow the logic again. So the logic always tells us total revenue is equal to P times Q. Okay, so that every time. So let's, again, I like to write the Q in front. We've got the P value. It's 24 minus 6 ln Q. Okay. So now it becomes, now we need to go back to some of the work we've done in chapter 5. But let's first see if we can do something about this. Do we want to multiply it in? What do we need to do? Okay, so I would say let's first multiply it in, but we just get some easier formula to work with. So Q times the 24 gives me the 24Q. Okay, so this one is the difficult one. So Q times that. So it is 6Q ln Q. So you don't change that, the ln Q. You only add it to the 6. And I think that is already something that in the, I would have probably, if I quickly looked at it, I would have wanted to say it's 6 ln q to the power of 2, because I would have quickly just wanted to say q times q. But if you go back to the rules, this is the rule that you also, if we go back to the log rules, this is what it is. So I think that is the first thing that we need to remember. Okay, so now we've got our formula of the total revenue, but still that is not the easy one to now do the marginal revenue. So let's see if we can get to a marginal revenue. So marginal revenue tells me that I need to basically do a derivative of that and a derivative of that. So the first one is easy, because that just becomes 24. But the second one is, that is not the easy one just to do. So now we need to go back to, I think this is where the product rule. So out of chapter 5, when we did the product rule, now again, one must remember what we did with the product rule. So it's unfortunately I don't have those. So let me quickly check. Let me quickly go to that and share. And I think that is the difficulty with this nearly, is that we need to nearly go back to some of the previous work. We need to, okay, so let me, I don't know if this is shared, so let me, I just want to share again. I don't think this is the right one I'm sharing, so let's, no. Okay. So is everybody seeing now the product rule function again on the slide? Just make sure. Just give me a thumbs up if you're seeing the product rule again that we did in chapter 5. If you see that slide again. Okay. Quickly, anyone, just one thumbs up when I know I have shared the correct slide. Cool. Okay. So when we look at the product rule, and that now, so that is why if we look at chapter 6, if we go into chapter 7, and if we go into chapter 8, that's the difficulty nearly, is that we need to know chapter 5 to do the rest. So the product rule basically, and was written as, we look at the first one. So we basically do the derivative of the first one, and then we multiply it by what the original was of the second one. Then we take the derivative of the second one and we multiply it by what the first one was. Okay, so let me see if I can share that we can go back into the one that we're working on. Okay, so just a quick thumbs up if you are seeing the one that we are currently working on with, that we can just can go back with that and quickly go through that example. So you are seeing again the 24 for the marginal revenue. Okay, awesome. Okay, so we basically need to, so what I can take out of that already is and again, always try to make it as simple as possible for you. So we now need to look at that. So let me, again, there's so many. Okay, so we now need to look at that. So for me, the first thing I will take out is a constant. That again, that we just work with the things that is simpler to manage. So then that is your one thing that you're working on, and that is your second term that you work with. So then by using the product rule, and I think that's important, so identify the first one that you work with, identify your second one. So then from the rules, basically that we have is we take the derivative of the first one. Derivative of q is 1. And we multiply it by the second one, which will be your ln q. Then the product rule says, okay, but now we need to do it the other way around. So we basically take q and we need to do the derivative of that. So now what is the derivative of ln q? And now, now if we go back into the log rules, so that derivative of that is 1 over q. So that makes it a bit, so that again is the log rule. Also in chapter 6, in chapter 5, that was also there. So this for me is nearly the most difficult one that you will get, because it takes everything nearly in chapter 5 that you've learned. It takes everything in chapter 6 that we are doing, and it's creating one massive equation, or nearly a headache for you. So, and just remember, let me rather do that we don't get confused with the, so we've still got the 24, we've got the minus that was there, but this now is the new equation that we got out of that. So let's see if we can at a point try to simplify that. So still got the 24. Okay, so let's just done that. Okay, so let's multiply in as well, so minus, so let me do it there, and we take that away so that at least we don't forget about it. So minus 6 times ln q gives me ln q. So here q times 1 over q gives me 1. So let's write this in better format as well, that I normally, so let's do that. So q, that disappears, so what we're left with is the minus 6. So then we have to, just to make that in a simpler format, we've got 24 minus 6, so that gives us 18, and that stays the same. It's the 6 ln of q. Okay, so that is our marginal revenue. So that is our marginal revenue that we have calculated there, or the marginal revenue formulas. So basically now what we still need to do is to calculate what that value will be. So to get that value and basically back to these scribbles that I did here, we need to make it equal to 0. So we now need to make it equal to 0. So 18 minus 6 ln of q is equal to 0. So 18 is equal to 6 ln q, because we've taken that to that side. So I can get rid of the 6 on this side. So I'm sitting with ln q. On the other side, 8 divided by 6 would have given me 3. So ln q is equal to 3. And then again, I think in one of the previous chapters, if we now need to work out what q is, basically the q will be equal to e to the power of 3. So when we get rid of ln, to get that rid of ln, we basically do the e in front. So e to the power of 3 is equal to q. And that, with a calculator, then we need to work out. But that nearly, if you look at it, it gives us 20.90. So if we round that off, it is 20 units that we have created. So now again, Siska, if where you were talking about the second derivative, so if we need to understand if it is an increasing function or decreasing function, we will work out the second derivative. So now the second derivative, we will need it to work with that to get to the second derivative. So if you now again work with that, it is, so let's just quickly see. So the second derivative of that, 18 will fall away because that is a constant. So ln q, remember the derivative of ln q is 1 over q. So that is 1 over q. So the second derivative then is basically minus 6 over q. Okay. So as you can see here, minus 6 over q. Because it's minus, q is always positive because you can't produce a negative number of units. So because there's a negative in front of a 6, that will always be negative. So that will always be smaller than 0. So if that is smaller than 0, what do we have? So if q is bigger than 0, tr is an increasing function. So again, I must check some of the previous papers if I actually ask, and it can be that they say work out, and they can give you the options to say marginal revenue is this, is it an increasing function or not? Marginal revenue is, or marginal revenue increasing function, marginal revenue decreasing function. So they can ask that. So in a sense, if I give you the second part with, then you know you need to do the second derivative. But this one is this is definitely the most difficult, and this wasn't easy. And that is why it's nearly a combination of all the previous work in chapter 5 and in 6 that we throw in together. Let's just get a few thumbs up. I know this one was a difficult one, and to follow also, But if we do it step by step, it is a bit more easier. But I think this is quite a difficult one to get your heads around. So I think practice this one a bit over the weekend as well. I'll check if there's any in any of the papers that I have available, if there's anything like this, because this is really like the most difficult one you will get. Okay, so we've got a few minutes still left, so let's see if we can get to most of the other ones as well. Okay, so if you look at the next one on slide 20 of question 3 or example 3, I think this one again a more very straightforward question. So I like these ones better than the previous one, to be honest. So first derivative, we can get that by basically doing the same principle. So if you look at the first derivative, it would have been that, and how we got that is take the 3 to the front, so the 3 divided by the 3 would have given us the 1. T3 minus 1 gives us the T2. Here what happened, the 2 again to the front, 2 times 5 gives us the 10. There was the original 1, 9 times 1 gives us 9, and the 90 disappears, so that would have been your first derivative. Yeah, so let's quickly look at what they asked in the question. So let's see, the output was that, with T is years, output in, we need to determine the number of years when output is a maximum and when it's a minimum. So basically we need to work out what the turning point is. Okay, so if we need to work out what the turning point is, we now need to factorize that. Again, now I would have done it is to get 1, it can only be 1 and 1. To get 9, actually it can only be, no, it can be 9 and 1, it can be 3 and 3 as well. Okay, we need to get to 10, so 1 times 9 gives me 9, 1 times 1 gives me 1, so 9 plus 1 gives me the 10, so there I'm sorted. So I would have gotten that T minus 9 times T minus 1 is the place where my turning point is going to be. So in the small graph here at the bottom, T minus 9 is my first one, so T is actually 9. T minus 1 is my second one, T is actually 1. So here you can see there's T1, there's your turning point, T9, somewhere there, and that's your turning point. If you now needed to work out what the Y values is, you would have gone back to the original and you would have said, okay, if T is 9, put it in there, get my Y value. If T is 1, go back into there and get my Y value. Okay, so the next point is it minimum, maximum? So then we need to look at the second derivative. So second derivative of that equation, again, I like it because it's much simpler. So t to the power of 2, so it will be 2t minus 10t, that will give me minus 10. So in this sense now, again, at t equal to 9, what do we get? So at t equal to 9, we get 8, which is bigger than 0. At t, what was the other one? At t1, if we put t1 in there, it would have been 2 times 1, which would have given us 2. 2 minus 10 would have given us minus 8, which is smaller than 0. So basically what that tells me is at that point, that was a maximum, and at that point, it was a minimum. So I know when I draw the graph, that's a maximum, so it must turn there. That's a minimum, so it must turn there. So that is basically what the second derivative did here for us. It is basically, it created that we get the turning point. And that is nearly, when I go back to the first one, where I wanted to explain here, and I think I then said it here as well, it depends on how many x to the power of what, how many times you nearly need to derive. So, and that nearly, Siska, is where you went already from nearly the first question into what we are doing now, is to, the first derivative basically tells me where the turning points are. With that, I can calculate the y. The second derivative tells me the way the diagram will look like. Okay, so first derivative gives me the x points or the turning points. The second derivative indicates to me how the graph will flow, if it is a minimum or a maximum. Okay, so that is example 3, just going more into the detail of the first and second derivative. I actually want to get to, so with example 4, I think please go and look at it, and afterwards you can WhatsApp me, because I want to get to just some of the elasticities before, because we only got a few minutes left. So let me just run through. So try this, and I think the important one with example 4 is when we get to the total revenue, the total cost, and we need to get we need to solve. It is not as simple again as some of the previous ones. So again, we will go back to, what was that, chapter 4 or 5 nearly, where we needed to work with that formula. So I think that again is important, that again we're going back into some previous work from previous chapters to get to the Q. So that is the only thing that I wanted to show here. The rest of the principle is exactly the same, how you work it out. If we look at the next example, this one again is nearly a easier one. They tell you what the total cost is. So now you need to work out total revenue. So here you need to work out a bit the differences. If we have time, I can come back to that. And then what we also, and I think this is important also, if we go into the next chapter next week, is you've got your total revenue, you've got your total cost. So if my total cost went through there, that would have been nearly my break even. So if my total cost is going through there, that portion is my, so okay, so sorry, that talk break even. Let's not confuse again, break even and equilibrium is two different. So that would have been my equilibrium if it goes through that point. Here it is basically, that is my profit if it goes through there. So where in the previous ones, when it was a straight line, it was very simple to look at the supply and demand function. very easy to see where it crosses, where's the profit, where's loss. And this will link back to when we get to next week, when we get to some of those consumer this consumer surplus, the producer surplus, where it is not the linear functions. And I know there was a few of those questions in the assignment, and probably something like that will also happen in the exam as well. So that is where we will get next week, is to say, where's the producer surplus, where's the consumer surplus in the nearly non-linear functions. So the last thing that I want to look at is, because I know there was some questions of this in the assignment as well, and there was questions about how do we work it out. So the elasticity for non-linear, when we looked at the linear function, it was nearly to say it was the minus 1 over b times p over q. So when we look at the non-linear function, it is a bit different. And I think that is important. Again, it is, so now we start to work with derivatives again to get into elasticity. So again, we look at what we've done in chapter 5 to work out here. And now again, one must remember that formula, but you need to remember what you're actually doing below the line when you say 1 divided by. So let's quickly go to one example. So what we've done here, let me make that also a bit bigger. Let's make that a bit bigger so that one can see that more clearly. So they tell us, consider the demand function, and they tell us, but we could have worked that out as well. So we could have worked out what the first derivative was, because if I do my differentiation, that will fall away. It will be basically minus 2q. So that we could have done as well. So it's not to say that they will give it to you in the exam. It can be that we need to calculate it. But basically, so we have now got that. So if you look at what they tell us, it's 1 over that. So basically what we need to then do is to say, okay, we've got that 1 over minus 2q. Okay, so now we need to go back to that original function, and we say, and let's do that times p over q. So that was the original, if we look at that, p over q, so that part was basically replaced with that. Okay, so now if we do that, we have p over q times 1 over minus 2q. So it will be p over 2q squared minus. Okay, so there you basically have your elasticity. That is how we worked it out. So at this point, I think we're 3 minutes left. So that is basically the first one that, so if we needed to work out the elasticity of demand, that is basically how we do it. Then if we now need to go back and we need to work out if we need to transform it again. So if you look at that, we've worked out the P, now we need to look at the Q. So we need to rewrite that first. So if we rewrite that, so let's take the Q to that side. So Q to the power of 2 is equal to 60 minus P. So I will need to say, okay, how do I get rid of that? Okay, so there you can see. So now we can replace Q into that function. So you will have in P over, so again, replace Q in there. So let's just write it out better that one can see why that happens. And there's a 2 in front. Okay, so basically square root to a power of 2, it just goes back to the 60 minus P, and we have a 2 in front. Okay, so that is where we got that. Okay, so then we basically have a minus P over 260 minus P. Then they need again to tell you what is the price, because out of that, otherwise that would have been my elasticity formula and answer. So they now need to tell you, or they would tell you at the beginning, consider the demand function for the price of 40 Rand, 45 Rand per unit, work out what the elasticity is. Okay, so they need to tell you that at the beginning. Okay, so this is how you will work out for the non-linear function the elasticity of demand. Okay, and that is, there is 2 more examples that you can go through, but I think that is 2 hours that went past very quickly, but at least I think we've covered again most of the work in chapter 6. So again, thank you guys for the ones that have joined in a bit later during the session. I'm just giving my cell phone number again if you want to join the WhatsApp group. I'll add you afterwards. What I'll also do again is I'll save this where I've done all the scribbles. I'll send it to the WhatsApp group. I will load it up to the system again on Teams so that you have access to that. The recording, thanks Bronwyn that you recorded, will also be available after this. And then next week, we haven't scheduled the time yet, but again it will be 10 to 12, and we will then just go on with chapter 7, and we'll follow the process the same unless there's comments that you want it differently, but I think it's quite nicely worked. And then I think what we can then do is towards closer to the exam, we can have 1 or 2 of these sessions so that we actually just go through some examples and some questions and work through that. Okay, thank you guys. Been a great session. Let me know on the chat and also on the WhatsApp what you think, and if there is other questions. But then have a great rest of your Saturday. Cheers, guys, and if you want to unmute and say cheers to one another, I don't have an issue with that. It's great to be part of this group, so thank you very much. And I'm going to stop the recording now as well.